So I typically like to give a shout out to the person who like got me in contact with the person that I'm talking to. And
Sure.
I love the fact that, we just met each other. We don't know each other from a bar of soap. Both cut from the same academic cloth, by the way. I don't know if you did a little Google stalking on me, but I was a professor in the Wildlife Fisheries and Aquaculture Department at Mississippi State University for 6 years.
I think I did know this. Yeah. Thanks for reminding me.
That's okay. You don't have to tell everyone that you Google stalked me. That's
But
fine.
but unlike me, you had the good sense to run away from academia.
I'll tell you what. Look, listen to me. I loved academia. I loved teaching kids and sort of inspiring them. And I'm lucky. I have a very good way of remembering people's names. I just have a knack about remembering people's names. And I used to teach the entry-level class called Applied Aquatic and Terrestrial Ecology.
Okay.
And what that class was supposed to be a filter system for the people, the bubbas of the world who like to hunt and fish, but did not have to become our resource managers to
Yes.
manage our resources
Okay.
from resource managers. And so I used to have, there was about 80 kids in the class, 90 kids in the class. And I'd memorize everyone's names because you get that little photo of them, right? Through the database of the university. And I would get the first day of class, I would say, you've heard me, you've heard my reputation in this class, that I know when you're here and when you're not here, I don't take roll in this class. I'll say, I'll tell you how I know this. And I'll pick up 6 people. First day of class. And I say, that person's name is this, that person's name is that person's name is this, that person's name is that. And they are shivering in their boots. They're like, oh my gosh, how does this guy know our names already? But I love teaching. I love seeing the kids today gainfully employed in the resource management business. I think that's the best thing about it. The publish and tenor, sort of, publish or perish kind of scenario. And look, I didn't like that. And I didn't like looking for money all the time, but I'm a non-profit executive director now, so I'm always looking for money. So anyway.
Yeah, that's a common theme no matter what the role, I suppose.
That's right. Well, Dan MacNulty, welcome to the Blood Origins podcast. I'm super excited to have you, super humbled that you said yes.
Well, thank you for having me. It's good to be here.
Dan, give everyone an idea of who you are and what you do.
Okay, so I am an associate professor of wildlife ecology in the Department of Wildland Resources at Utah State University. I've been involved in wolf research for nearly 30 years. I started in November of 1995 as a field technician for Yellowstone National Park's Wolf Project.
Wow.
That was that was the first winter that wolves were on the ground. They had been released the previous March and the first batch. And then I followed them around with a couple other technicians, one of whom I still work with, Nathan Varley. He runs an ecotourism company called wolftracker.com now, but he was also a wolf researcher, and we worked together. Chase Davies was the third technician. And this was at a time when, nobody knew you could watch wolves in northern Yellowstone, right? I mean, everyone expected wolves to be sort of mysterious, hanging out in the trees. We wouldn't see them.
Right.
But we were coming back from the field every day with these crazy stories of things that we saw. Wolves hunting, chasing after elk. We'd actually see kills firsthand. We'd watch wolves interacting with other packs. Just all this great, direct, observational content, I suppose. Things that we would see that you would typically expect to see, like only if you were in Africa, right?
Had anybody done that sort of that observational work in wolves at that time, Dan?
Say that one more time.
Had anybody had that experiential observational data set on wolves prior to this whole Yellowstone picture coming together?
Yeah, so Dave Meach had done a lot of pioneering observational work on wolves, sort of in two places. One was Isle Royal, He and Rolf Peterson. Rolf Peterson was after him. All that work on Isle Royale, though, was behavioral observations from aircraft, fixed wing aircraft. It was all very short, brief glimpses of wolves through the trees. Whereas with us in Yellowstone, we're just sitting on the road or up on a hilltop, hours on end, watching wolves, just seeing the complete suite of behavior from start to finish. The only other place where that had really been done was also by Dave Meach, and that was up on Ellesmere Island, up in the high Arctic of Canada. And before that, there's been some behavioral work done in Wood Buffalo National Park by Lou Carbon. Let's see, Olas Muri had done some work up in Denali back in the 50s. Yeah, so
were their experiences different than yours, i.e., in the shadows in the woods kind of scenario, or were they like, wow, same thing as you? Like, whoa, these guys are out in the open and
that
and
was all open. So up on the Ellesmere, there's no trees, it's wide open, more open than northern Yellowstone. Up in the tundra around Denali, Muri was able to observe wolves hunting caribou out in the tundra, and honestly, if you go to Muri's observations that he details in his book, the interactions that he saw of wolves hunting caribou are almost verbatim of what we've seen of wolves hunting elk. I mean, if you crossed out caribou and wrote in elk and read the description, you would think that you were, reading an account of wolves hunting elk in Yellowstone. I mean, the behavior was really quite similar.
Mm-hmm.
So we kind of pioneered the direct observation of wolves in Yellowstone back in the mid 90s, and I sort of took that opportunity, turned it into graduate work, focused specifically on the behavioral interactions between wolves and their ungulate prey, primarily elk. And then I started to study in 1999 in the interior of Yellowstone, where the only available prey for wolves to hunt in winter are bison, because the elk migrate to lower elevations. There's a series of thermal areas in the interior of Yellowstone, in this particular valley, that kept at the time a number, probably about 100 or so bison that were cows and calves, of adult females and young, and they were the target of wolves that lived in that area. And we were up on a hilltop observing the behavioral interactions of wolves hunting bison. And at the time, that was pretty unique, because the only other place in the world where wolves were seen hunting bison were in Wood Buffalo National Park with Lou Carbon's work. And so that was also, I would say, pioneering work. And we would see these epic, encounters between wolves and bison. Epic in the sense that they would last sometimes for days. Bison are extraordinarily difficult for wolves to kill. It's like attacking a bulldozer. And they're very cooperative, the bison are, in how they defend themselves. But wolves are just extraordinarily patient, right? They just, that's one of their greatest skills that we don't really think about, but they're extremely patient, and they wait and they wait and they wait until the bison got themselves into a corner or crossing over into deep snow, and the wolves would sort of spring into action and pick one off. But it was very much a game of chess between wolves and bison.
Mm. So you've progressed on. Have you been a professor at Utah State since you leaving Yellowstone, your graduate work?
So in terms of my timeline, so I did my master's and my PhD at the University of Minnesota. My master's was with Dave Meach. My PhD was with Craig Packer, who's known for his work on lions in Africa. But all of that graduate work was focused on work in Yellowstone on wolves. And then I did a postdoc with John Vucetich at Michigan Tech, still working on Yellowstone wolves. And then after that postdoc, I came to USU in 2011. So I've been here, going on 12 years.
Still got Yellowstone wolf research happening?
Absolutely. Yeah. It's a system that's continuing to change. in a system like this, where you can't readily do experiments, unlike the Hobbs study, by the way, where they were able to do some experimentation, in general, the only way to understand a system like this is to study it over a long period of time.
Right.
And so, every additional year is, an additional insight about how the system works. And there's been such massive change in my, almost 30 years that it's only really now just kind of getting interesting in a lot of ways.
Yeah, well, that's the sort of fortuitousness of the situation you're in. A lot of people have 2 to 5 years in a place. You try and figure out, some sort of correlation, some sort of trend, and you move on to the next one. Very rarely do you have these long-term LTER kind of data sets that span decades.
Absolutely. Yep. It's unique. The other thing that's unique about the Yellowstone system is that, unlike other long-term studies, take like the lion study in Africa with Craig, or the Isle Royale Wolf Moose study, they've developed time series, but maybe just time series of 1 or 2 species. What's unique about Yellowstone is that we have time series on multiple species. So time series on wolves, elk, cougars, aspen, willow. So we really have a sort of multi-trophic level time series that gives us tremendous opportunity to really understand mechanistically how these different trophic levels are interacting, and really puts us in the best position to tease out cause and effect. Because in a system like this, that's the challenge. It's like, what is the cause? What is the effect? And when you're not able to do experimentation, all you have are these long-term data sets. And what you need are lots of those data sets.
Right.
Because ideally, you're interrogating each of these different data sets in different ways. And ideally, they're giving you the same answer to a question that you're asking. And that's what gives you confidence that your answer is correct. If all these different data sets are basically pointing in the same direction.
Yep. Dan, let's rewind the clock a little bit to classic ecological texts that use the Yellowstone environment ecosystem prior to wolves as an example of trophic cascades.
Okay.
Can you set the scene for? Do you know what I'm talking about? I would assume you do.
So, are you referring to how Yellowstone was characterized prior to the wolf reintroduction?
The whole no, with the wolf so leading into what Hobbs has just come up with. So in classic ecological texts, it's the whole too many elk took off the willows, beavers scenario. Wolf came in, took care of the elk. Beavers came back, willows came back. Beautiful, everything worked hunky dory.
Yeah, so that's sort of the cartoon version of what's transpired since 1995, since the wolf reintroduction. And that's also the version that's conveyed in the How Wolves Change Rivers video. That's quite popular. And actually, incidentally, that video was just recently remastered and updated. What's curious about that, though, is that the imagery is slightly updated, but the content and the message is unchanged. The narrative is exactly the same as it was over 10 years ago. So the facts and information in that video are just as inaccurate now as they were in the original release of that video.
Well, let's talk about the original release of the video and the facts in it.
Yeah, so they attributed a lot of change, ecological change, to not only the effects of wolves on elk numbers, but also on elk behavior. The storyline was that elk were terrified of wolves and went out of their way to avoid wolves, and that in turn led to effects on vegetation, increases in height growth.
Elk was spending time around the rivers, knocking down the aspens. Wolf came in, dispersed the elk. The elk were terrified of wolves, dispersed the elk away from the riverine areas, riparian areas. And aspen trees grew back.
Yeah, and that in turn stabilized soils, and that changed the the configuration of the river channel and so forth. And one of the first things I did when I started here at USU in 2011 is I started work on understanding more clearly the effects of wolves on elk habitat selection, behavior, kind of getting at that whole behaviorally mediated effect of wolves. There had been some initial studies that were done using GPS collared elk. The first GPS collared elk ever was like in 2001, approximately. There was sort of a 5-year study. And they came out with the folks working on that published some papers, one of which was pretty famous, sort of suggesting that there was in fact a behaviorally mediated trophic cascade on aspen. And we re-examined those data together with additional data collected in the years after that. And what we found in this study was that, yes, elk did adjust their behavior to wolves. However, they were not absolutely terrified of wolves. In other words, they would often use risky areas at times of the day that wolves were inactive. You think of wolves as being, these great nocturnal predators, but in fact they're not. They're more sort of like twilight, daylight hunters. And so the nighttime is sort of a free pass for elk in a lot of ways, and they're using these risky areas. They're browsing on aspen, they're browsing on elk, on willow. And so that study, this was a monograph that Michael Cole was a lead author on, that was published in 2018. And that kind of, I would say, rejected the hypothesis that elk are absolutely intolerant of wolves on the landscape. In other words, they can't coexist with wolves in space. They can most certainly tolerate wolves in space. And at that time, they did so by basically taking advantage of times of the day when wolves were inactive. And they did the same. We found evidence that they did the same with cougars, too. So when cougars are active, which is at night, the elk are out in the open grazing. And that's out in the open is where the wolves are oftentimes most successful. But it's nighttime, 1, 2, 3 in the morning. And wolves, for the most part, are sacked out at that time of day, that time of night. And so elk are sort of threading the needle, so to speak. And they're able to exist on the landscape, obtain the resources that they need to maintain body condition, maintain pregnancy levels, etc. They were able to coexist. And this shouldn't really be too terribly surprising because elk and wolves have coexisted for thousands of years. Elk, or if anybody knows anything about elk, I think there was an old professor here at USU that I'm fond of quoting, who said that the only thing that limits elk are bullets and air. And I think that's true. They're extremely hardy animals. They're very robust. They can deal with wolves. They can deal with cougars. And what we found, so now we're kind of fast forwarding a little bit in terms of understanding the cause of the decline in elk numbers, is that it was the combined effects of multiple predators all acting on elk at the same time that was actually really the driving force for the decline following wolf reintroduction. And so, just to back up a bit, basically, the behavioral effects of wolves on elk, at least in the northern Yellowstone system, as conveyed in that How Wolves Change Rivers video, are wildly exaggerated.
Right.
Okay? And so most of the work then shifted towards understanding, well, how are wolves contributing to changes in elk abundance densities? And one of the most important things to realize is that before wolves had even been brought down from Canada, the elk population had already notched its first year of decline. Okay, and so we had their peak was in the winter of 93, 94. That was right before the reintroduction. And in the winter of 94, 95, before wolves were even released, elk numbers had actually started decreasing.
Hmm.
And this is oftentimes confusing to the public because they'll see that the wolf reintroduction the first year of 1995, that when wolves were released, that corresponds to an elk decline. But the elk decline was actually logged before wolves had even been brought through the gates of Yellowstone and before they were released in March.
And so what do we think that initial decline was caused by, Dan?
Most likely it was caused by hunting. So the northern Yellowstone elk population is migratory. It winters sort of partly inside, but also partly outside the park, and then it summers inside the park and on Forest Service lands surrounding the park. And when they leave the park in the wintertime, they're exposed to hunting. And for a long time, starting about 1978 or so, the state of Montana had a regulated harvest that not only they had one that happened in the fall, a fall harvest, but also what they called a late hunt. And this would be like January, so that sort of that time period. This was during the time when elk were on their winter range outside the park. And it was an antlerless hunt, meaning that they were targeting primarily adult females. And the reason for this was because the state of Montana was wanting to reduce numbers of elk in order to minimize damage to agricultural, field infrastructure, fences,
Yep.
that sort of thing. And so just to give you kind of like an idea, so like in that winter, 94, 95, we notched the first sort of decrease in elk numbers. There was over 2,500 elk that were removed just in that one winter.
What are we talking about in terms of the overall population at that time, Dan?
At that time, the total number was, what do I have here, 94, 95. It was around 20,000. Okay. And then the year that wolves were released, 90, see, so about 20,000 in the year that wolves were released, and then they started dropping after that.
Did the late season hunt continue?
Yeah. It continued until about, 2000, the winter 2009, 2010 was the last year of the late hunt.
Okay.
And so from the time that wolves were released in March of 95, clear through to the winter of 2002, 2003, so 8 years of wolves on the ground, hunters were actually removing a larger share of the elk population than wolves were. There was 1 year where they took, this was in the winter of, let's see here, I'm just looking at the data to make sure I get this right for your listeners. The winter of 96, 97, hunters removed a total of 3,320 elk. And that's combined late hunt and the general season hunt. But most of that was removed as a result of the late hunt. Almost 2,500 elk were removed. So meanwhile, wolves were killing, a mean of about 500 elk per year in those first 8 years, whereas hunters were removing about 1,600 elk per year for those first 8 years, from 1995 to 2002. So wolves were contributing, but hunters were contributing massively to the elk population decline shortly after wolf reintroduction. And this shouldn't be news to anybody because this was published extensively in that sort of early 2000 era. So John Vucetich had a paper in Oikos that he co-authored with Doug Smith and Dan Staler. Greg Wright had another paper in Journal of Wildlife Management that emphasized that hunters were removing, because this was an antlerless hunt, they were removing the reproductively prime animals. So these were animals that were pregnant. So it was kind of a double whammy. You're taking out, mom, but you're also taking out the calf that she would have produced that spring. And so recruitment rates decreased as a result of this, as well as the overall numbers of elk. And so that kind of set the stage for elk population decline. Hunting of prime-aged animals. Wolves were contributing by killing the young, the calves, but they are also taking out the older elk. These were females and males, but if we're talking about females aged, from about 10 on, that's sort of the age range that they really target. Meanwhile, you had other predators. You had, besides humans and wolves, you had cougars and bears.
Yep.
There was a study that was published in 2006 by Shannon Barber Meyer pointing out that bears were just absolutely massive predators of elk calves on the summer range. Grizzly bears and black bears, and then cougars are also big predators of elk calves as well. And so essentially, you have this sort of perfect storm of predation operating.
Took the words right out of my mouth.
So this goes back to what I was saying about elk being super robust and hardy, and then they can deal with predators. But in this case, when you had humans, wolves, cougars, black bears, grizzly bears, so 5 different predators, all targeting different components of the herd, the calves. By the predators, hunters were taking the prime-aged animals, wolves were taking the older animals. There was really no escape from predators, essentially, and so naturally the elk population decreased. But the late hunt was ended in that 2009-2010 winter. And their numbers the elk population has started to increase, I've got that figure.
Did it bottom out? What did it bottom out at, Dan?
Yeah, I can, just give me a second here.
No, that's fine. That's fine.
On my fingertips. It's in our book. Just give me a second here.
Whilst you're looking, we'll plug. You have written a chapter in a book.
That
describes this a lot.
Yep, this is Yellowstone Wolves, Science and Discovery in the World's First National Park. This is co-edited with Doug Smith and Dan Staler and co-authored with numerous researchers. I don't think I know exactly how many, but gosh, it must be at least 30 different co-authors on the various chapters. But let's see. Elk bottomed out. The Northern Yellowstone elk herd reached the bottom around 2011, 2012 at approximately, this is not adjusting for citability, this is raw numbers, so this would be like 4,000 or so, 5,000.
Okay.
And they've been ticking up since then, since about 2011, 2012.
And so the change, let's just talk through the change that occurred. We lost the late season, so we lost one predator in the system. Any other changes in the predator dynamics post 2010, 2011?
Well, wolf numbers leveled off. Grizzly bear numbers, there was a recent study that just came out. I don't know if their numbers sort of started to plateau around then or not. I'd have to go back and look at the figure to give you a for sure answer. Cougar numbers, the ones that I'm familiar with, indicate that their numbers also sort of leveled off. And the other important component here is that because this is a migratory herd, and they leave the park, they're leaving the park and going into an area in which there are few wolves, generally speaking, in the wintertime, because those wolves are under hunting pressure. And so those elk are exposed to less predation from wolves, specifically on the elk calves. And so that's important because it's overwinter survival of elk calves where it appears that wolves have one of the greatest effects on elk population dynamics is that overwinter survival. Because I told you earlier that Shannon Barber Meyer demonstrated that, yes, wolves are killing calves in the summer, not to the same extent as bears are, but in the wintertime, when those bears are in hibernation, those calves have to survive the winter to recruit into the population the next spring. And the wolves are really having an effect through their predation on the elk calves together with the mountain lions. Well, If you have a lot of elk that are wintering outside the park where there aren't a lot of wolves or a lot of mountain lions, then those calf survival, overwinter survival rates are higher. And that's contributing to the increase in the population, this higher recruitment rate as a consequence of higher overwinter survival outside the park.
Dan, is there a age point in which an elk calf / yearling is then sort of, beyond quote unquote typical reach of a predator like a wolf?
Yeah. So once they get to about age 2, so basically once a calf gets to become a yearling, the risk of being killed by wolves is substantially less. It's even lower still once they reach age 2. So age 2 is sort of a great place to be if you're, and I'm talking adult. Let's just talk female elk because
sure.
they live longer than the males do, and that's where we have most of our data. Which is important to point out because there's a lot of concern about the effects of wolves on the harvest of bulls.
Right.
And what people should understand about our study in Yellowstone is that all the collaring that we've done over the last, since 2000, 2001, has all been on adult female elk and elk calves, but we have not put collars out on bulls. And the reason for that is because those adult females and the calves, they're the components of the population that are contributing to population growth. And so that's why we focus on them. So that's why what I'm about to tell you is just focusing strictly on adult females. And so once they reach age 2, basically from 2 to approximately 10 to 12, somewhere in there, elk have very high survival, very low risk of wolf-caused predation. They're difficult for wolves to kill. Once elk exceed about age 10 or so, then their risk of wolf-caused mortality starts to increase, and more of those older elk are killed. And so I told you just a moment ago that the effects of wolves on the elk population are manifested primarily through their predation on elk calves. However, there is some effect that's also manifested through their predation on those older females, those 10 and up females. Because in the absence of wolves, those older females would continue to live. And we do still have a substantial amount of old female survival despite
what's the typical life expectancy of those old cow elk, Dan?
So given that a female reaches age 2, the median lifespan is 17. And
what?
That's in the presence of wolves.
In Yellowstone?
Yes. These elk are
17.
Really, 17.
Dude, I would have lost money.
I know. That's why I didn't ask you to guess because I knew you'd get it wrong. So what this means is that 50%, so once an elk reaches age 2, an adult female, 50% die before they reach 17, and 50% continue to live beyond the age of 17. And we're talking about our sample of collared elk. So how many is that? Because that's how we came up with that estimate. That's based on probably, what do I have here?
Are they still reproducing? Are they still producing calves after 10?
Yes, but it's lower. Their pregnancy rates start to go down, but they are still capable of producing. So, like here in this graph from our book, we had almost 300 females that were being monitored from 2000 to 2017, and that's where we came up with that 17 as median lifespan. And so the other sort of anecdote that's really interesting is that up until recently would be like the last 5 years, we were collecting collars off of elk that had been killed by wolves, and these elk had actually been born before the wolf reintroduction, and only basically within the last 5 years or so were being killed by wolves. So they basically survived this gauntlet, this predator storm that we were talking about. They survived that, and only now are beginning, or within the last 5 years, were being killed by wolves. So these are elk that are living to 19, 20, 22 years of age. So elk are an example of what we consider like a slow life history organism, something like an elephant or a whale. And they're not quite that long, but, a much longer lifespan than an elk. So they invest all their resources, so to speak, into survival. That's where the action is for elk in terms of understanding their ecology. It's all about survival, specifically for the females. And so, the elk population dynamics are really sensitive to that. And so that's why when you had hunters taking the prime-aged females and wolves taking the more senescent females, survival of both of those stages was being depressed at the same time. That helps explain why the population really started to decrease, from basically 1994 on to about 2011 or so.
Dan, where's the population today?
Well, we're on an upswing. I'm looking over on my computer screen to remind myself where the most current data would be. Oh, well, where it would be? It would be in the Hobbs piece, the Hobbs paper.
Okay.
They have the most current estimates of elk numbers, and I think it would be I forgot what they published, if it's just for the elk that winter inside the park or if it's the total numbers, but it's also corrected for citability. So the elk numbers are, I would say, probably somewhere in the 6 to 7 range, total numbers of elk in the northern Yellowstone elk population. So that's the segment that winters outside the park plus the segment that winters inside the park in northern Yellowstone.
Do we think, I'm just scrolling through the Hobbs paper right now.
Yeah.
What are your thoughts so if we think the elk population currently is in the 7,000 to 8,000 range, do you think, based on your research, do you think that 20,000 elk was an overly inflated number of elk?
Overly inflated?
In terms of just numbers of elk on the landscape, it was that. Or and maybe let me add to that. Do you have any idea or thoughts to sort of a cyclical predator-prey kind of model in an elk abundance in Yellowstone? Did we go through the lowest of the low, now we're climbing out to some other peak, and then over time we'll go back into a valley?
I mean, this is why we study the system, right? Because we don't know what's going to happen. And history can only take us so far, because, one of the things that Rolf Peterson and John Vucetich, who've studied the Isle Royale system, the Wolf Moose system there for so many years, one of the things that they've said that always sticks with me is that, no 10-year period in their time series is like any other 10-year time period. And what that means is that, the past is not necessarily an accurate guide of the future. And so what we've seen in Yellowstone since the wolf reintroduction, to what extent is that predictive of the future? It's hard to say. What I think is certain is that we'll continue to see an increase in the elk population, in part because of this sort of spatial refuge that elk have when they winter outside of the park. I don't see that spatial refuge changing. And what I mean by that is wolves and cougars continue to be hunted out there in the wintertime, so their numbers will be low. It's doubtful that Montana Fish, Life, and Parks will reinstitute some sort of late hunt. They might. There's a lot of friction between landowners and elk on that north end of the northern Yellowstone elk winter range. So this is the portion that's outside the park. Mm-hmm. And, they might, and they do have some sort of limited sort of damage hunts kind of thing, but nothing on the order of what happened back in the 70s and 80s. And so given that, I would anticipate the elk population to continue to increase because of that spatial refuge. Yeah. So does that answer your question?
Yeah, it does. It does. The other, I guess the biggest question that I really reached out to you about and was the research you've done, which is specifically on elk and
Yeah.
population dynamics of elk and behavioral changes tied to wolves, what is, I know you're an academic and don't say it depends, okay? But what is the relationship between wolves and elk in Yellowstone? Have wolves had a detrimental effect on the population? I know we've just talked about the multiple predators and whatnot, but sort of take a 30,000-foot view. Did they change their behavior because of wolves in the landscape? It doesn't sound like the population, is suppressed to the point where there's hardly any elk anymore because of wolves. So I'd like to hear your opinion.
No, to answer your question, are wolves detrimental to elk in Yellowstone? I would say, at least with respect to the northern Yellowstone elk herd, no, I don't think so. Because it depends on what you mean. Like the term detrimental is a bit value laden.
Yeah.
And
Did they cause a decline in the population?
They certainly contributed, no doubt. They contributed. But what we do know, based on some of the modeling work, is that if it wasn't for let me put it this way: you can't explain the decline in the elk herd solely on the basis of wolf predation. They just weren't killing enough elk. Mathematically, it's not possible. You only get that decline when you also add into the population model the contribution of hunters. The removal of elk as a consequence of that late hunt contributed massively to the decline. Without that, you wouldn't have had as steep of a decline. Yes, there would have been a decline because of wolf predation, cougar, bear predation, but it wouldn't have been nearly as dramatic as what was observed.
One of the interesting things you mentioned was at the 2011, 2012 sort of point where hunting got removed. I think you said that wolves had almost stabilized, right? You had your wolf packs had stabilized in and around maybe 2014, maybe 2015, maybe a little later.
Yeah.
Do you think, again, hypothetically, I just, again, opinion, like to know your hypothesis on this. As you're building, and it makes logical sense, as you're building a predator base, increasing their abundance in terms of wolves in their pack, would they have more an effect on elk than now what we're seeing? Wolf packs are very much stable in the Yellowstone ecosystem, and elk are now starting to recover. Again, thinking in my brain, I'm trying to think through almost like a predator-prey cycle kind of scenario that may occur.
Yeah, I mean that's right now it seems pretty stable, you know. And it just, I mean, that's an excellent question. Honestly, it's like, are you going to see, swings in elk and wolf numbers like you see swings in wolf and moose numbers on Isle Royal? Possibly. But see, the difference between Isle Royal and Yellowstone is that Yellowstone is a far more complicated food web. You've got more species, more links between species. Instead of single predator, single prey, we've got multiple predators, multiple prey. We haven't talked about all the alternative prey that are available to wolves. There's deer, there's moose, there's bison. Mentioned bison, but one of the things to understand about bison, because they're so difficult to kill, most of the biomass, that bison biomass that wolves consume, is actually from bison that die of other causes. So they do a ton of scavenging, and that could be contributing to the stability so far of wolf numbers that we're seeing and elk numbers.
It's a great point.
The other thing to be aware of is that wolves are very sensitive to disease, canine distemper virus. And we've had, you look at the time series of wolf numbers, and there's been drops periodically. And those drops have corresponded to outbreaks of canine distemper virus. We don't know anything really about what drives the frequency of those outbreaks. Is it due to the cycling of the disease within the carnivore population inside Yellowstone or outside Yellowstone? To what extent might unvaccinated dogs be contributing to this? But that's certainly one of the sort of stochastic factors that could really, reorient the direction of the system and cause some instability potentially. The other thing that's a source of instability is the hunting of wolves outside the northern boundary. Okay, so a couple of years ago, I don't know, 23 some odd wolves that were basically Yellowstone wolf packs that were spending most of their time in Yellowstone were picked off when they crossed the boundary.
Mm-hmm.
That creates instability in the sense that it leads to increases in reproduction, because wolf population growth is density dependent. So when densities are low, population growth is high. When densities are high, population growth is low. And so sudden drop in density as a consequence of harvest boosted reproduction, and we actually had a bit of a spike or an increase in numbers of wolves. That's gonna create that creates conditions for instability. It's still too soon I would say, to say whether that it has in fact led to instability, but it is a potential source of it. And so, in terms of what happens next in the next 10 years, depends upon whether these disease outbreaks happen again, the extent of harvest of wolves on the boundary, and then what happens to the bison population too.
Well, I think that's the most important thing, and I think the most eye-opening thing to me is obviously there's multiple players on the landscape, multiple players from a predator perspective, and multiple players from a prey perspective, and Yellowstone has that bison component in there. And how much does that contribute to elk population stabilizing, increasing, decreasing, versus a system like Idaho, which is what I originally reached out to you about? Like, hey, I want to know the truth. I want to know, like, are wolves impacting elk in Idaho the way that people are saying that they are, or is it just a fallacy? And me as a scientist, I should have kicked myself in the ass to hope for just a black and white answer, because it's never that way, in that it's so nuanced. In that, again, Idaho system probably doesn't have bison. Maybe it has something else like mule deer or whitetail or antelope or something like that are sort of this, again, an additional player in the system that with and without them would have we don't know, but hypothetically could have ramifications on population dynamics of elk, regardless of whether it's wolves or not. It could be just the fact that you don't have bison.
Yeah.
Or you don't have X,
My understanding, and I haven't studied that system, but just as an outsider, my understanding too, depending on if you're talking like the Lochsa, sort of northern Idaho area, it habitat change and forest succession has been a big part of that story. A lot of fires went through that area in the early 20th century, created outstanding elk habitat, and since then, those areas have reforested to some extent, and so it's not as ideal elk habitat as it once was. I believe habitat change is part of the story up there, part of one of these other factors that needs to be considered in terms of understanding the dynamics of the system and why you have low elk numbers there. In northern Yellowstone, the habitat for elk, I would, in terms of grassland abundance, that has been pretty steady. We had the fires of '88 that definitely impacted the area. Not so much in northern Yellowstone as elsewhere in the park, but the food base for elk and for other grazers primarily is really outstanding. It's a very productive system. That conceivably could change in the future as we continue to warm. The lower elevations of the northern Yellowstone winter range are quite dry in the summertime, and perhaps that could have a role going forward in terms of being less productive winter range in the future than it has been in the past. So, that's the mystery of what happens in the next decade or two is really what drives me. I want to know what's going to happen next. It's sort of like this ecological thriller that you really can't take your eyes off of, because there's so many interesting players, and humans are a big player in the system. I think that's the other take-home message from the work that I've done in the last few years, is really highlighting the role of human beings in the dynamics of the system. Like it's really you're mistaken if you think about Yellowstone as being this sort of wilderness laboratory, okay? Because human beings play a massive role in the dynamics of the system. Human beings in terms of like the hunters that we talked about, potential for disease transmission, if we're talking about, people, the millions of dogs that probably visit Yellowstone every year, maybe they're not all vaccinated. And then human-caused climate warming. That's a huge contributor. And there are others. We're talking about, the lake trout that were introduced to Yellowstone Lake by human beings. There's evidence to suggest that had cascading effects on the terrestrial side of the system that impacted the elk population, because grizzly bears had fewer native cutthroat trout to eat, and so therefore they switched their predation to elk calves. So you can't think about the ecology of Yellowstone without thinking about the role of humans. That is just such an important take-home message, because if you go back to what you asked me before, the sort of textbook, characterization that we hear about wolves and how wolves change river, none of those characterizations fully acknowledge, the role of human beings in the system, and of course, humans eliminated wolves and they brought them back. So that's the most obvious role that we've had, but there are other more subtle roles. And so it's really crucial to take account of those roles and to be aware of what those impacts are, and to include them in your explanations of what has happened and what's going to happen.
Yeah, and I think, to add to what you just said, I think it's dangerous to speak in the definitives of cause and effect if you think it's one thing and another. And it's also that all of our systems are very, very complex. They, as you said, we've said multiple players, multiple predators, multiple pieces of prey, adding a human fingerprint on it in whatever shape or form you can think of, whether that's small, like, as you say, lake trout being introduced, that you think it's a good thing for people to recreationally fish in a lake and it's cascading effects through the system, or, climate change that's causing habitat shifts that we actually have no idea their effect on a certain prey population and its abundance change, and how that's cascading through the system. So don't just take it as black and white and it's this or that. It's super nuanced.
Keep an open mind is sort of my policy with all this, and be prepared to be surprised.
Exactly. Well, Dan, I really, really appreciate you coming on, man.
Sure.
I love these kind of conversations. It sort of tickles the scientist back inside me. And thank you for being so kind and not calling me out when I said detrimental. You were very, very kind to say, man, that's a little biased there, Kroger. You should have you forgot your science roots for a second.
No worries.
So much appreciate you, Dan.
Okay, good talking to you.
All right.